Okay, welcome to Kojo's Math. It's been a while, but it's time to hit the deck running because we got a lot of work to do in this last few months of school. So today we're talking about ratios. Ratios are not that difficult if you remember the definition of ratios. Ratios are written as a quotient of two numbers or a fraction. They're written as a fraction, and they have to have the same units that you're talking about. So if we're talking, some of you will remember that you read this, you don't see 3/4, the fraction is 3/4, but it's a ratio. If I tell you it's a ratio, it's 3 to 4. So you read ratios as 3 to 4 because you're putting something together like fruit basket. You want it to be colorful and you're going to make this giant fruit basket. The boss tells you he wants for every 3 apples, he wants 4 oranges. And he wants you to fit as many as you can as long as you have that combination. So you'd have 3 apples and 4 oranges because of the colors that he would like to have. So you'd say, well, apples and oranges are different, but they're not. They're fruit. So you'd say, we're talking about apples to oranges, the ratio of how we want to mix them together, but they're fruits. So that you're talking about 3 fruits to 4 fruits, but then you're specifying which fruit. That's really important that you grasp that concept. Some of you are used to writing it with a colon, 3 to 4. That's fine. I'm not going to count off if you do that, but you have to recognize that 3 to 4 can be written as a fraction. All right, so let's say that the Sparks, we wanted to compare their wins to their losses. We're not talking about total games. We're talking about wins to losses, okay? So if they had 6 wins to 8 losses, we want to know what that means and what kind of prediction we could make. Well, it's wins and losses, but we're talking about games, hence the same units of measure. Even though you're talking about games won and games lost, you're still talking about games. They're the same units of measure. So they have 6 wins, 6 game wins, and 6 game losses. So we write that as 6 to 8. We write it as a fraction, and we simplify as 3 to 4. What does that mean? That means that out of every 7 games that they play, we expect them to win 3 and to lose 4. So we can make a prediction based on this. 6 to 8, we would say out of 16 games, we'd expect them to win 12 games because we still, for every 7 games that's played, or for every 3 out of 4, we expect every 7 games we'd have 3 wins and 4 losses. Okay, so it's a ratio as a comparison of data. Okay, and the units have to be the same. Remember that because sometimes you're given information where the units aren't quite the same yet, but you just have to make a simple change and you can get it to be that way. Okay, so now you see them in word problems, and I kind of took shortcuts. You can too when you're writing your notes. Richard correctly answered 6 of 9 questions. Eleanor correctly answered 12 of 18 questions. Jack correctly answered 7 of 14. I want you to find the ratio. Ratio is always written in simplest form, simplified fraction, so that you can break it down to see who has the best results. So we want to find the ratio's correct answers to incorrect answers. The unit of measure being answers. One is incorrect, one is correct. You have to write it the way it's described. We wouldn't write incorrect first and then correct because they tell you correct to incorrect. So Richard has 6 to 9, which simplifies to 2 to 3. He has 6 correct to 9 incorrect. Eleanor, 12 correct to 18 correct. Notice I'm not writing the units in the fraction because you don't. They cancel each other out. In a ratio, you never have units in your final answer. Never. Because they just want a comparison of data. So 12 to 18 becomes 2 to 3. And Jack, 7 correct to 14 incorrect, 7 to 14 is 1 to 2. Who's got the better answers, the better score? Richard and Eleanor. Because they had, out of every 5, they get 2 correct and 3 incorrect. Jack is a 50-50, right? Type of thing. Or 1/3. He's got 1 correct answer to 2 incorrect. So they are doing better because they answer out of 2 out of every. They get 2 correct to 3 incorrect. But every time he answers a question, you can predict that he's going to get 2 wrong. Okay? All right. So now You're just looking to see which one is the best. This one confuses a lot of people. Shaded areas. The question is going to be, what's the ratio of the shaded area to the entire area? The perimeter of the shaded area to the perimeter of the entire area. Those are the questions. So it's going to be area. It's going to be the perimeter of the shaded area compared to the perimeter of the entire area. Very tricky. For instance, okay, look at this. You got to look at this. You got to be careful. Where's the shaded area? It's right here. It's this rectangle right here. And it cuts inside the bigger picture, the bigger rectangle. So the area, the perimeter of this is 8, 8, 4, and 4 inches. And we're going to add that up. 4, 4 is 8. 8 plus 8 plus 8 is 24 because it's shaded. And we write that down. You have to write it down. Shaded area, perimeter, P, to entire area, P. That P is for perimeter. So we don't write inches because inches, everything is in inches. You don't write inches in a ratio in the final answer. You just write the fraction. So then we do the entire area. People make mistakes. We're talking about perimeter. We're talking about this area, this perimeter of the whole shape. That does not include the interior shaded measurement. This is not part of the perimeter of the larger shape, so we don't include that 8. We count this side, which is 6, this side, which is 6, this top, which is 8, and the bottom, which is 8, because the shaded area is inside the area. We do not count interior area measurements for perimeter. So we get 8, 8 is 16, and 12, right? 8 plus 8, this 8, this 8, these two measurements and that. So we get 12 and 8 is 20, and we get 28. So over 28. So the shaded area is 24 to 28. That's the perimeter. We have to simplify that. What goes into both? 4. So we get 6 sevenths. So it's 6 to 7. That means for every 6 units here, I would have 7 units to make it stay ratio, proportional. Okay, just remember that. That's the relationship. There's 6 to every 7. Okay, right now we're talking about the perimeter. So if we opened all this up and we laid it in a line, for every 6 units for the shaded area, there's 7 units that would be, so they grow the same. That's the relationship of it. Okay, so I want you to try this one. And I want you to pause the video and find the shaded area to the entire area perimeter. Okay, and these are tens. Okay, pause the video, and when you're ready, come back, start the video, and check your work. Welcome back. Let's see how you did. I think I did this on a different one. Yeah, okay. So first of all, we have shaded region to entire region, perimeter. We want to put perimeter over perimeter of entire region. So here is the shade, here's the entire region. We did not count the interior measurement. The entire region, which goes on the bottom, because we're comparing a small area to the larger triangle. So we have the entire region is 10, 20, 30, 40, 50, 60. 60 inches goes on the bottom. And then we have the shaded region. That goes on the top because that's smaller. We want the perimeter of the shaded region. So that's this measurement. And we use the interior measurement because this is the shaded area. So we have 10, 10, 10, that's 30, 40, 50. So 50 inches over 60 inches. We don't need inches. You cancel that out. We get rid of that because we do not write the units in the final answer of a ratio. We're left with 50 to 60, which simplifies to 5 to 6. That's the ratio. Now there's one thing I'm going to point out here that doesn't look like a ratio originally. If I give you something like 6 inches over 3 feet, Right now, that's not a ratio because the numerator is inches and the denominator is feet. But you can convert that. So we can make feet into inches and make it a ratio. You have to do that because right now you can't compare inches and feet. You can't do it. They're different units of measure. So you can't do it, but we can convert feet to inches. So we keep 6 inches, and how many inches are in a foot? 12. In the inside of your back of your book, the very back, so you open the back cover, there's a whole list of conversions. You need to learn, make yourself familiar with those. So 12 inches in a foot, 3 feet is going to give me 36 inches. Now, that's a true ratio. We have to simplify it. Gotta cancel out the inches. Get rid of them. We're left with 6 over 36, or 6 to 36, that's the ratio, and it becomes 1 to 6. No units in the final answer. So for every 1 inch, there's 6 inches in the other thing that you're comparing. All right, that is the video. And what you're going to do is you're going to write down 2 things that you learned and 1 question you still have. You also